Well, okay, grade 12s. Let's have a look at examples involving the co-ratios that we dealt with in earlier years in grade 11. And just to recap quickly, if you look at sine 90 minus a or something, do you remember that that was cos a? And we're going to make use of this. In fact, we're going to reverse the formulas, and likewise cos 90 minus a would be sine a. Okay, so we're going to reverse those kind of things quickly. Okay, so let's see what happens now if you have some other equations that come up as well. For example, if I said to you, if you look at the equation sine A equals sine B. Okay, now, because it's sine, we can drop the sign, so to speak, but there's two options. It links up in exactly the same way as your other equations. So a is equal to b, alright, and we go plus k 360. The other option here with this one is a is equal to 180 degrees minus b, exactly as you would do with normal trig equations, except we're not going shift cos here. When you talk of cos a is equal to cos b, then the same thing happens. There are two options, but this time a is just going to simply be plus minus b plus k 360. Okay, so you treat it exactly the same, but you don't go and shift cos. And likewise with the tan, if tan a is equal to tan b, what you would do there is you'd say a is equal to b plus k 180, all with k being elements of z. So these are the main types: the one with cos, the one with tan, and the one with sine there. All right. Okay. Now, what I'm going to do is I'm going to look at an example. Let's have a look. Say they said to you solve for x here, and they said tan 2x is equal to tan x. How would you solve for x here? Well, because it's a tan A, tan B, and we don't really have a formula for tan 2x as well, what I'm going to do is I'm going to say, okay, fine, no problem. 2x is x, drop the tans, but then add k 180 to that, where k is an element of z. So then all you do is bring that x across, and x is equal to k 180. There we go. So that's the general solution of that. They might even put in a bit of a restriction. Say they said if x goes from, let's make it minus 360, we'll include them to 360. Well, what you could then do is you could quite easily draw up a little table. So you could say, let's pick some values for k, minus 2, minus 1, 0, 1, and 2. Let's try those. And then, of course, our general solution is this. So if we plug in 2 in there, so negative 2 times 180, negative 360, that would be negative 180, 0, and then if it's 1, it's 1 times 180 is 180, and 2 times 180 is 360. And I think beyond that, that wouldn't work. So you've actually got yourself 5 answers here. These would all be part or specific solutions to that. Obviously, if the restriction got more, you could, include more values. Okay, now another one I want to show you where we use the co-functions. If you have sine x is equal to cos 3x, very awkward to work with 3x because you don't have a formula for cos 3x. So what I could do though is if you think of this as a and that is b, well, what do you know about sine 90 minus b? It is equal to cos of b. Okay, so what we can then do, if you look at this, is we can say, okay, fine. We're going to go backwards. We're going to say cos b, this one here, is the same. So we're going to make them both sines. So that is sine 90 minus the b thing, which is 90 minus 3x. Do you see that there? And that's brilliant because now we're in a position to apply the rule for sine. Now, what is sine? There's two options for sine. The one said drop the signs. Okay, and then add k 360. That's the one option. So then you get 4x is 90 plus k 360 and divide everybody by 4. So that would be, so x would come to about 22,5 plus k 90 as your one option there. Okay, the second option, if you go back to these here, look at sine, as the second one would be this one, where it's 180 minus the b thing. So you go and say the second option would be x is equal to 180 degrees minus this whole thing, 90 minus 3x plus k 360. So what does this come to? 180 minus 90 plus 3x plus k 360. And then x will be, okay, this is 90, pretty easy, plus 3x plus k 360. And then, of course, what we can do, bring that across, x minus 3x is negative 2x, is 90 plus k 360. And if we divide both sides by negative 2, you get negative 45 minus k 180, which, of course, is your second general solution to that equation. Okay, so these are very valuable kinds of equations that you can deal with. So these could be extended to other things. So for example, you might have, you could take it with cos. Say for example, cos x is equal to cos 20 degrees, and you want to solve for x without using a calculator. You could go x is plus or minus the 20, drop the cos's, but don't forget to add k 360, and where k is an element of integers. And you can actually verify that, because if you look at this, if you take x as 20, the cos of 20 will work, that's 20. The cos of negative 20 works, because that's still cos 20. If you go bigger than 360, so what would be that? So it's 20 plus 360. Well, once again, if you simply subtract the 360, you get cos 20. So these work, and so these rules that I've given you are very, very important. Okay, and another one, if you have a look at this, say for example, we have tan x equals negative tan 20 degrees. Well, what you could do is you could go tan x is equal to the tan of negative 20 degrees. You see, because the tan of negative is that, and then you can simply say x is equal to the negative 20 plus k 180, and where k is an element of z, and there you've got it. And it works, because if you think of it, if k is naught, the tan of negative, if you take tan of negative 20, that actually is negative tan 20. So in fact it works. And if you go bigger, so say it's if k is 1, so what's that would become tan of 160. Okay, and if you reduce that, it's tan of 180 minus 20, and because you're in the second quadrant, again it's negative tan 20. There we go. So there we have it, people. And such an amazing mathematics is, and links in beautifully to trig graphs, especially when you get the points of intersection. Sometimes you might have various kinds of equations that you can deal with, and it's something that's quite important there. For example, there's many ways you could do it. Like say sine 2x, for example. If that equals sine x, where's the graph of sine 2x equals sine x? Well, you could simply drop that there and add k 360, which would give you then x is equal to k 360. Or of course you can go, you can go 2x is equal to 180 minus x plus k 360. It works as well. So that gives you 3x is 180 plus k 360. Divide both sides by 3, and off we go. There we go, and that's the answers there.